The next demonstration we're going to look at we call Magdeburg Hemispheres. We also have a variation called Magdeburg plates that I'll show you in just a minute. Now you can read about the original situation where they used teams of horses to pull apart large brass cylinders, but I'm going to leave that as something you read in the book or Google. It's very interesting, so Google Magdeburg Hemispheres and read about the original experiment on your own. Today I want to just show you how to work our setup. So what we have here, I did a quick measurement and you can see that this is, these spheres are about, say, 4 inches in diameter. I did a quick calculation, and that means the cross-sectional surface area is about 12 inches squared. Now when you put air pressure on that, we know that the atmospheric pressure is about 15 pounds per square inch, or 14.7 psi. And I did the math on this. If you had a perfect vacuum inside, so no air inside, and normal air pressure outside, the air pushing outside would force you would have to exert a force of about 180 pounds to pull these two apart. Now we're never going to get a perfect vacuum inside, but we could see that only with the greatest of force could these two spheres be pulled apart. That's the original verbiage used in the Magdeburg Hemispheres. So I like to say, only with the greatest of force can these two spheres be pulled apart. Now I have a volunteer, Rob Meyer, come on out here, geology instructor here. Let's show you how this works. We've got this vacuum pump here, and what we can do is we can turn this on very briefly. I see that this side's putting out the air. Let's go ahead and connect the hose. All right, all the way on. Don't worry about the gauges. They've been broken for a long time. There's a little O-ring in here. You should not be touching this O-ring, but if for some reason it gets popped out, you want to put that in there. Okay, very delicately. Try to minimize your amount of contact. You want to keep the surface as clean as possible, all right? But kids are going to play with this, so you know it's going to get messed up sometime. So I'm going to go ahead and turn on the vacuum pump for a few seconds here. There we go. Now I don't need to hold it together anymore. I've got this hose clamp. So I can crank on this hose clamp and make sure this stays together. All right, so that's about how long it takes to evacuate this. And what I've done now is I've just sealed this so air can't now re-enter the area between the spheres. So we can go ahead and take this off of here. All right, Rob can grab one side, I can grab the other, and when we pull on this, you can see that only with the greatest of force can we pull this apart. That's the Magdeburg Hemispheres. Sometimes we'll have this set up for little kids where it's actually hanging and they can hang on it, because a kid, in theory, could hang on this if you had a good enough vacuum. While we've got that set up, let's show you the other variation. This is the Magdeburg plates. This is a little bit easier for us to set up. So again, this emphasizes, you could see the area a little bit easier. The cross-sectional area is clearly pi r squared. That's a common misconception. People think, oh, the area I should use is 4 pi r squared, but that's not right. In this case, remember that some of the air pressure is pushing down and that's canceled by some of the air pressure that's pushing up, so you only need the component that's horizontal here. Now in this case, we take these two plates. Rob, could you hold these for a second? Thank you. So when you're attaching this device, you want to start with the plunger all the way down so you can get maximum vacuum, and attach it here, thread it in just like a screw, and then pull out. And then whoa, unscrew it, grab the plate, and we can pull on it. And again, only with the greatest of force can we pull this apart. That is the Magdeburg Hemisphere or Magdeburg plate demonstration. All right, let's try one more thing. This is a fun puzzler you can stick kids with. Rob, can you hold this for me for just a second? Okay, so I'm going to go ahead and evacuate this real quick. I attach this when the plunger is all the way down. Then I pull it out. So I get a nice strong vacuum there. Untwist. Okay. Now go ahead and grab this. Don't pull too hard on this. But as we pull on this a little bit, a fun question to ask is who is pulling more? Right? When you're pulling on this, if you're basically having a tug of war here, so you can ask the classic question, who's exerting more force? Rob or me? Now in this case, it's a pretty easy answer. Since we're both named Rob, you say Rob must be exerting the largest force. But in this case, we're exerting the same amount of force, right? If we try and pull this apart, even though, say, Rob's bigger than I am. Now, if it's accelerating like this, even if we're moving at constant speed this way, we would say we're still exerting the same amount of force, even though Rob is winning the tug of war. But if it's accelerating that direction, then clearly the force that way is larger than the force this way. So that's a way you can mix this up. So watch out. If it's moving at constant speed or at rest, not moving, people are exerting the same amount of force. If it's accelerating one way or the other, that's when one of the forces is larger. That's the Magdeburg hemispheres and plates.